In this Algebra 1 video, we're in Chapter 5, Lesson 6, Graphing Inequalities in Two Variables. Now, technically we're going to be graphing linear, so I'll put in that in parentheses. Our objective is, as the student, I can solve and graph linear equations on the coordinate plane because I will combine what I know about inequalities and linear equations. Specifically, when I'm talking linear equations, I'm referring to the most common form that we use the most, y equals mx plus b, slope-intercept form. As a review, m stands for the slope, and b stands for the y-intercept. That's where it gets its name, slope-intercept form. The key characteristic of slope-intercept form is y is all by itself. So that's what we're going to do for each of these. We're going to use those skills, and we're going to graph, but then we're going to do a little bit of shading, like how we did on regular inequalities. Like regular inequality, say the answer was here, shade to the right. We're going to do that, but now we're basically going to do that on the coordinate plane when we have two number lines. So we have one number line this way, one number line this way. Hey, that's a coordinate plane. Some of you might be thinking how, and I'm going to tell you, just like y equals mx plus b, meaning, as a crash course, get y by itself, graph the y-intercept, graph the slope from the y-intercept, etc. So skip some space for the stuff right below it, but let's jump to a quick example so we can remember that, and we'll do it with this. Like I said, skip a little bit of space for that stuff at the bottom, but now over here, let's take a moment just to review. Like I said, slope, or technically y-intercept, we'll do that first. But either way, the slope is the thing in front of x. Well, the thing in front of x is 3. Oh, and by the way, before you do any of this, you got to make sure y is by itself. And look, y is by itself, so you can skip that step. Well, the slope is 3. Technically, the slope is 3 over 1. It's positive, so that means our line is going to go up 3 over 1. Now, we need to know the y-intercept so we know where to graph our first point. Well, our y-intercept is going to be the number that's over here, the constant term. So the y-intercept is -1. That means it crosses the y-axis at -1. So let's get that set up. I'm going to slap some graph paper down on here. You can just quickly sketch it. It doesn't have to be perfect, but I'm going to. Now, honestly, the graph paper really isn't that necessary. I care more that you're understanding how to where to shade, dotted, solid, which I'm already foreshadowing that stuff at the bottom. But for the sake of reviewing and doing it accurately, I am going to use graph paper, and if you have your own, go ahead and bust it out. Otherwise, you'll be just fine if you just kind of sketch this relatively accurately. Alright, so y-intercept of -1, that means go down to -1, put a dot there because that's where it crosses the y-axis. Step 2 of graphing linear equations is graph the slope from the y-intercept. Well, the slope is up 3 over 1, so up 1, 2, 3 over 1. So we'll put a dot right here. You now have the path to draw your line. Now, I'm going to use the line tool and draw it precisely, but more importantly, we got to now look at the difference. Graphing it was just like what we're used to learning, but now let's go finish what we skipped spaces for. Then we'll come back to this and finish it. When you look over here, write down what I have at the bottom. Press pause if you need to. Take a moment to write it. So once you know where your line's going to go, you've got to now determine some things. You've got to determine whether it's going to be a solid line or a dotted line. And when you do that, it's just like when deciding, is it a filled-in circle or an open circle when we were just doing single variable inequalities. Remember, if it does not have the or equal to on the bottom, it does not include that number. And so it's going to be an empty circle. Well, now similar concept, it's going to be a dotted line. Whereas if it does have the or equal to, it includes that number. So before it was a filled-in circle, but for now it's going to be a solid line. That's the difference. Whereas this one's going to be a dotted line. Okay, so now you determine whether it's a solid or dotted line. Like I said, we'll come back to this other piece. Let's go use that to draw our line. We know where this goes, and we see that our example has or equal to. So that means our example is a solid line. So when you graph this, you can go ahead and use a solid line in order to do so. So I'm cheating. I'm using the line tool to make mine perfect, or as perfect as I can. And there we go. Alright, so we said it's going to be a solid line that we established. I went ahead and graphed it with a solid line because it has the or equal to. Now, the second part is you have to decide, is it shaded above or below? And I gave you some shortcuts. The way you determine is if its y is greater than, it's going to be shaded above. Same thing if it's greater than or equal to. If it's greater than, it's shaded above. If it's less than or equal to, it's shaded below. As long as y is by itself, meaning as long as it's in slope-intercept form, you can use this. Now, the logic reason, you don't have to memorize this, the logic reason to decide is this. Does y measure up and down, or does y measure left and right? And you already know the answer to that. Y measures up and down. So because y measures up and down, it's saying the answer is everything that's greater than your line. Well, everything that's greater than your line is everything that is above your line. So in that example, that would be above. So actually, let's go ahead and use these lines as our example. So for this one, greater than, it's going to be shaded above. For less than, it's going to be shaded below, because everything down here is below that line. So even if the line was going in the other direction, so let me switch the order of that second one. So I just changed the order of those lines. Even if it's greater than, for this example, this one that's less than, it's gonna be shaded below. Below is down here, and for the other one, greater than, well, that's above. That's up here. So regardless what direction the line's going in, you can either shade above or below based on is it greater than or less than. In our example, it's greater than. So the answer to our question is shaded above. So what you're going to do is you're going to graph your line with a solid line, and then with your pencil, slightly shade in everything above the line. And so the line combined with the shading, that is a complete answer to this question. You've graphed this linear inequality. Alright, so you give this one a shot. And now before you do, I'll remind you, you'll notice this does not have y by itself. This is not slope-intercept form. In fact, this is called standard form. So if you want, you technically could use all the things you remember about how to graph standard form by finding the x and y intercepts. But honestly, in my opinion, the fastest way for most of these questions is just get y by itself so it's a slope-intercept form and take it from there. So hit pause. Give this one a shot. Alright, so to get y by itself, you got to start by getting rid of 6x. It's positive 6x, so you move it by doing the opposite, which is negative 6x, or minus 6x. So, cancels on the left side. So on the left side, you're left with 3y greater than. Now notice, these are not like terms, so you keep them separate. Go ahead and put the x first, since we know y equals mx plus b. Let's get in the habit of putting the x first. That 12 is positive, so it's plus. The 6x was minus, so it's negative. Finish by dividing both sides by 3 to get y by itself. Now remember, it's the entire right side divided by 3. So the 3's cancel on the left side. That was pretty straightforward. So you have y greater than. Now, negative 6x divided by 3. Negative 6 divided by 3, well, that's negative 2. So we have negative 2x. Now, 12 divided by 3, well, that's 4. It's still positive, so plus. So our equation is y is greater than negative 2x plus 4. That's what you're doing. Now do it exactly like we did this one. Alright, identify your slope. Your slope is the number in front of x, so your slope is negative 2. Technically it's over 1. It's negative, so that means our line is going to go down 2 over 1. Our y-intercept is 4. It's going to cross the y-axis at 4. Alright, so let's go put a dot at that. 1, 2, 3, 4. So y-axis of 4. The slope is down 2 over 1. 1, 2 over 1, so right there. Okay, you now have your two dots, but it's time to draw your line. But make sure you know whether it's a dotted or a solid line. And if you remember, if it does not have or equal to, meaning it does not include, the answer does not include this line. It's just everything above it, but it does not include it. That means it's going to be a dotted line. So graph this with a dotted line. All right, so there's my line. Now I'm going to use the eraser and make it dotted. Okay, so you've got your dotted line. You've established that. Now the last thing you got to do is you have to decide whether it's going to be shaded above or below. This is greater than, and because y measures up and down, and our answer is everything greater than this line, that means our answer is everything above this line. So you'll shade this above. Now, that's one logical way to explain where you're shading, but there's technically another way, and it's a way that you need to be aware of because you're going to have questions that are going to ask you, are certain ordered pairs a solution? So this sounds like a side thought, but technically it's another example because you're going to use this for some of your questions. So basically the question is going to say, are the following points, or which one of the points, or name a point that is a solution to the graph. Now I'm going to show you visually how to check and algebraically how to check. So we're going to check to see if the point 5, 4 is a solution, and we're going to check to see if the point negative 2, 2 is a solution. And basically what you do, the visual way of doing these is you graph them. Well, 5, 4, go graph that. 1, 2, 3, 4, 5. 1, 2, 3, 4. That's right there. 5, 4 is right there. Negative 2, 2 is right here. Now, that was an ugly dot. You'll notice 5, 4 is within the shaded region. So visually, yes, it is a solution because the solution is everything in here. But negative 2, 2 is not in the shaded region. Therefore, it's not a solution. Even if they named the point that was on your line, like that point right there. Because the solution does not include the line, it does not have or equal to, if the dot had been on the line, it would not be a solution. And now that's the visual way of checking. The algebraic way is plugging it in, meaning plug in a 5 right here, plug in a 4 right here, and checking to see if it's true. And you'll notice negative 2 times 5, well, that's negative 10. So you would have negative 10 there. And then negative 10 plus 4, well, that's negative 6. So you have 4 is greater than negative 6. Well, that's a true statement. So therefore, this is a solution. Now, if you're going to try the other one, plug in negative 2. 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. Well, remember, this is going to be a 2 if that's a negative 2, based on this. I just made up those points. Anyways, so we'd have 2 is greater than 0. So, excuse me, I think I plugged that in wrong. 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. So 2 is greater than 0. Okay. I see my mistake. Okay, a negative times a negative is a positive. Alright, so negative 2 times negative 2 is positive 4. Positive 4 plus 4 is 8. So we have a big old fat 8 over here. So we have 2 is greater than 8. Well, that is a false statement, and that's why this one is not a solution. For some reason, I kept getting a true statement when I was plugging it in just now, but it's because I was rushing. So this is a false statement, because when you plug in negative 2, that's positive 4, plus 4 is 8. Well, this is a 2 according to this. So 2 is not greater than 8. That is a false statement. Alright, so that's the algebraic way to check, and the visual way to check. Is it a solution? Teachable moment, guys. Everyone makes mistakes, just like I just did, but when you rush. But take your time, show your work, and just remember, everything is a learning opportunity. You make a mistake, no big deal. Just learn from it, and then now you've improved yourself. Alright, so keep going. Try this one. I'm not going to explain this one quite as in depth, but I want you to give it a shot. Hit pause and see what you can do. Alright, start by getting y by itself. Notice, because you added 24x, that makes it positive 24x over here. And because this was negative 48, that's why it's minus 48. Those things basically mean the same thing. Alright, finish by dividing both sides by 8. Remember, it's everything on the right side divided by 8. So 24 divided by 8 is 3. Negative 48 divided by 8 is 6-ish. Alright, so now that you get y by itself, go ahead and identify the slope and the y-intercept. Alright, throw down your x and y axis and go ahead and put those dots in place. Alright, if you need to, hit pause for a moment. Graph the y-intercept of negative 6. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5. Alright, so that's y-intercept negative 6. Slope is up 3 over 1. 1, 2, 3. 1, 2, 3 over 1. So right here. Alright, now if you're not sure if that's accurate enough, feel free to throw another one down. Go up 3 over 1 again. Alright, so now graph your line. It's going to be a solid line because it has or equal to. And it's greater than, and everything that's greater than is everything above it. So it's going to be shaded above. Alright, get your line down. And like I said, it's greater than, so everything's shaded above. And if you ever forget which side it's shaded on, go ahead and plug in a test point. You could plug in, I don't know, let's say this point. Plug in negative 2, comma 1. And if you plug in negative 2, comma 1, you're going to get a true statement. So it means it's shaded on this side. If you plugged in, say, something over here, 1, 2, 3, 4, 1, 2, 3, 4, 4, negative 2. If you plug in 4, negative 2, for example, so 4, negative 2, you would get a false statement, meaning it's not shaded on that side. So it's a quick way to check yourself. Alright, guys, so that was one more example. We're going to do one more, we're going to say one more thing, and we're going to be all done. Actually, I'm going to hold off. There's one more point we need to make that you'll see on your assignment. We'll talk about it in class. It's not a big one. But basically, the main idea is everything we've talked about, how to graph. So just recap, just make sure you understand those steps. It's just like regular linear equations. So get y by itself, graph the y-intercept, graph the slope. Then just sides, solid line, dotted line, shade above or below. And that's the main idea of everything you've got to do for each of these questions. So take your time. We'll work on word problems. We'll take it a little bit further. And we'll mention that one other small thing. It's a very easy skill. It's something I'd rather just do in person. All right, you guys take care. I'll see you in class.